Hello, everyone. Thank you for joining us. Today, we will have a webinar session about AI's growing role in AdTech. Our speakers today are Dmitry Maranik and Alexey Rosolovsky, which is me. We are architects at Lineate. And we will begin our talk with a real-world example of AI-powered product campaign setup. And then we will proceed with a demo of a technology used. Let's start with a quick market overview. So our clients are using AI and machine learning in AdTech for a long time, primarily for traffic shaping. It's used by ad exchanges, and the idea is to forward an ad request only to buyers who most likely will be interested to participate in auction. It also includes different ML optimizations, such as dynamic bid floor or dynamic bid pricing. And also big area is personalized ads, where a certain part of an ad is dynamically constructed on the fly, depending on page context or audience information. And those use cases may continue, but they are orbiting around classification, clusterization, regression, and similar AI and ML applications. However, recently, with an increase of power of AI solutions and specifically development of large language models and their ability to better interpret and process large amount of textual data and extract key points from this data, we see a big interest in using AI for shifting to first-party data strategies and contextual advertising. Where AI can extract, for example, audience segments or content segments from the content. And it's especially important with third-party cookie deprecation. Another use case is where AI can help to analyze campaign configuration and campaign performance statistics and make recommendations about further campaign settings or even automate them. And finally, we see that AI can help to distinguish visitors with higher customer lifetime value, and which can be used for lookalike segmentations. And the primary focus of our today's talk is automation of product placement campaign configuration. And let's start with the problem description we tried to solve for one of our customers who has multiple AdTech products, and one of the products helped content owners to monetize their articles and blogs. The problem was that the process of setting up the campaign was completely manual. Product owner had to create for a specific page an ad placement and then manually pick a product relevant to an article from a product catalog. So we decided to try an idea of using LLM to completely automate this process, because we saw previously like LLM applications where it was able to pretty successfully respond like on a questions like, is this page good for audience A, or is this ad is good for audience B, or for example, if it's an app, it can answer for a question what audience this app is for. So we decided to try to use LLM for product placement campaign configuration. And on a high level, our solution consisted of three key steps. The first step it's understanding the content, which starts with extracting the content itself. And we considered multiple options, which has their own pros and cons. Like, for example, front-end based text extraction. It uses or it borrows the CPU time and network bandwidth and page load time from the visitor itself. But it bypasses a lot of limitations that backend-based or crawler-based extraction solution has. We also considered using LLM capability to download the content link that some of them has. Then after the content is extracted, we push this content to LLM system to extract keywords, segments, audience recommendations, and key information like brands and so on. This is what we call understanding the content. And after those key elements are extracted, we use them to search for relevant products that can be used for product placement campaigns. And finally, those products were embedded into the page content itself. In more details, the solution looked the following way. In the middle, we had an orchestrator that received extracted content, and then it called multiple related services to turn the content into product ads. And as I mentioned before, the first service we called was the LLM system that gives us key information. And on this step, it's worth to mention that basically our product ads, they are relevant to the content itself, and the content doesn't change too often. So it completely makes sense to introduce caching layer on this step because you don't need to reanalyze the same article over and over again. And then extracted key information was forwarded to Search API that uses semantic, which is vector search or lexical search, to extract relevant products from a product catalog. And finally, extracted products were wrapped as an ad markup and embedded into the page, taking into account publisher placement settings. Like the example of such settings may be like brand safety or visual settings. Like, for instance, if you are writing articles about Apple devices only, you may want to not have ads that, like, for example, have devices from other brands. This is like example of brand safety. And the search itself can be done in two ways. It was mentioned in a previous diagram, using lexical search solutions such as Elasticsearch or Solr or similar solutions, and semantic search, which is a vector search. And lexical search is good for more exact types of matches, like, for example, SKUs, brand names, product codes, like, or size or color of a product. And semantic search is better to use for meaning match. So if your product catalog contains good description of a product, it allows you to have a good match against extracted key points of the article without a need to configure synonyms or anything like that. And the ideal result you can achieve by combining both types of searches into one hybrid search, and your search API must re-rank results from both systems by a formula that you may come up with. And again, just worth to mention that the nature of the system is that content doesn't change too often, so caching in multiple places will allow you to save a lot of infrastructure costs. So that's the solution we built, and here is the result. This shows you a product ads that were embedded into an article about CTV and Roku TV specifically. And the key result here is that those ads or product placement ads were added into the blog post completely automatically with zero human intervention. And you just need to place one tag on the whole web site, and for each your article, similar ads can be automatically generated. In terms of future development of the system, we have plans to introduce publisher UI to actually provide access to knobs to configure UI behavior and visual customization of ads. Like, for example, how many ads you want to see on a page, what kind of font or color or background you want to see, and things like that. But even those things can be automated. And also another idea of tracking ads performance, and if certain product ad is underperforming, we can dynamically replace it from a catalog with a different product. And again, as I mentioned, we're also considering applying AI to other types of campaigns or types of configuration. So we explained how we extracting the key information from an article content using LLM. And now let's see a real world example how this technology works. Like it's similar solution, but allows you to turn text into AB content segments. So now I'm switching the microphone to Dima. Please go ahead.
Thank you, Alexey. The problem that we aim to solve is how to map the content that users are reading on their websites to IAB taxonomy interests and segments, which will allow us to send these signals and make ad traffic more valuable to buyers. As a simple description of the process, we are taking websites, contents, put it into categorization requests, and sending it to our custom AI assistant, which is basically a combination of out-of-the-box AI assistant with vector store that contains content taxonomy that we pre-processed and put there. As a result of this process, we will have a category object which represents the content of the website. We decided to use this article about family travel as part of our demo. You can see that it has quite a lot of different information. And also we are using this content taxonomy file, which contains all categories that we are interested in from IAB GitHub. Okay, let's see how this thing works. Let's start the application and talk about it a little bit. You can see that I'm creating a custom AI assistant with a prompt to look for the best match for the content within the uploaded file and return JSON object, which appears exactly as in the file. Quite simple. I'm uploading the downloaded file and putting it into vector store. I use my AI assistant and associating vector store with it. So now everything's ready to do the client run. As a request, I'm sending just the URL for the content. OpenAI API allows us to do that. And as a result, you can see that we got a JSON object from the file as we requested with category related to travel and more specifically about family travel. You can see that this is a great way to benefit both publishers and advertisers. Publisher, it's make it easier to monetize traffic because it becomes more enriched, and for advertisers, they can buy ads about family vacation only if visitor comes from a narrow targeted content about it. Let's talk about costs a little bit. So based on our runs and our implementation, we can see that the average cost for 1,000 articles is about $2.50, which is not bad. Of course, there are some ways to save money, and without OpenAI, there are two options. You can use batch processing to pre-process all existing articles. It gives 50% discount right away. And from the use case perspective, it makes total sense to do that. And the second option is to use smaller embedded models that are specifically created for classification purpose. And both these options could be combined to achieve the best results. To address privacy concerns, we should mention that OpenAI claims that they don't use data sent from API to model training, and it is possible to achieve BA and HIPAA compliance by request. Obviously, there are multiple OpenAI alternatives right now. So if you are in AWS shop, it makes sense to use Bedrock, which provides a variety of available language models to use to play with. Azure AI, OpenAI is very similar to OpenAI API with some nicer UI and low-code options. And if you have concerns about your data safety, data privacy, or if you have a lot of data, it makes sense to look into spinning up your own RAG with, for example, LangChain and Llama, which can be a great way to achieve that. In conclusion, just wanted to reiterate that LLM demonstrate really promising results in extracting meaningful context from content. The solution can go beyond text, so it's possible to apply it to audio, podcasts, video, even images to process and work with it. And last but not least, it's just an exciting opportunity for AdTech companies and publishers. It opens doors to improved content categorization, more precise targeting, and innovative revenue generation strategies. Fun fact, the last slide was created with LLM based on previous slides in this presentation. If you have any questions, don't hesitate to contact us. We will be happy to discuss them. Thank you for your time, and hopefully we'll talk soon.